try that. There, let's pull it out. See what kind of reading we get this time. Pretty close. Okay, that's good for that one. Go on to the next step. I finished the piston. We got the proper height figured out on it now. We did get the wrist pin hole drilled and reamed out to 188 thousandths as per requirements. And the next thing we have to do, this is already taken care of on the when I originally machined these pistons, 1/4 inch depth, 750 thousandths diameter, and then we drilled it out, and that actually provided a clearance space for cutting the slot for the connecting rod. So now we're going to be using the same fixture, and what we're going to do now is we're going to push the piston all the way down into the fixture, and the reason for that is we're going to get a lot better holding by doing that. But we're going to line up the wrist pin holes with this slot right here, because we need to have the slot that's going crosswise here has to be perpendicular to the wrist pin holes. So let me get that lined up here. And I'll tighten it in. A little bit more pressure on that. Just going to try and make sure it's not turning anywhere. Checking the alignment here. Alignment's just a hair off. So we're going to loosen that. Loosen that part. We're going to twist it twist the piston just a little bit. Check the alignment on the other side. Looks good. Okay, tighten it back down again. Yeah, we don't want this moving because you know what kind of rotational forces that end mills put on these things. Okay, the plans call for 343 thousandths. And I don't have a 343 thousandths end mill, which would be 11/32, but I do have a 5/16. And it took a while to find the 5/16. So anyway, what we're going to do is we'll cut that slot out, you know, this way, and we're going to have to machine like about 15 thousandths on each side. And let me see if I can get the camera moved back a little bit. So maybe I'll move it over to this side. Be able to see a little bit better what's going on. Yeah, there we go. That ought to work. Okay. We set it at 0 and they want the depth to be a total of 750 thousandths, so we're going to take it down 500 thousandths from where it's at right now. Now let's see what kind of a mess we made out of this slot. It's never an easy job to do. Just down at the end, tighten her up a little bit so we get that out of there. Lefty loosey, righty tighty. It's a little rough looking in there. Needs to have some deburring done, but it's pretty well met the criteria for what we need to do with that slot. Kind of hard dimensioning that with a 5/16 inch end mill. Let me measure that and see how close we came to the required dimension. I did everything as close to the book as I could. We're at 354 thousandths, or about 11 thousandths over. When you're just using dials to figure out your depth, and I went, since I had 313 thousandths on the end mill, I needed to go 343. I went 15 thousandths on either side, trying to take the backlash out. There's a lot of backlash in this machine. Trying to take the backlash out and doing the 15 thousandths on either side. But I was still ended up about 11 thousandths over. I don't know. I don't think that's critical for this type of part. I don't think it is, but it is perpendicular to the holes that were bored in the sides, and so that should be good. All right, I'll bring you up for the last step in this machining. Okay, the final step on the piston is drilling the oil holes around the bottom oil compression ring. If there's ever a time that you're going to have the heebie-jeebies about drilling holes, it's usually when you're drilling with a 52 thousandths drill bit with a Bridgeport milling machine. And also you're drilling 8 holes, which doesn't divide evenly into 36. And there is a method for doing this, and I'm not sure how that method works, but I'm going to show you my take on drilling 8 holes on a spindexer. And we'll just get started right now. So we got our pin pressed in at 0, which is where we're going to start. And with a small drill bit like that, I like to go a little bit faster than I normally go on larger drill bits, so that it can clear the chips out better. Okay, now what I do is remove the pin from the 0 position when I move it up to 5. What that does is that matches up with 45 degrees, which if you divide 8 into 360 degrees, you come up with 45 degrees, and since this is marked off in 10-degree segments, that's the closest thing to that particular division you want to get to. So now what I'm going to do is I'm going to move the ring up, and I'm going to be keeping my eye on the 0. And whichever one comes closest to this fitting into a hole, that's where I'm going to put it. Whether it's a 34 or whatever. Okay. we've got it locked into the 34 now. So that's our first division. Another thing I like to do is lock this into place after each movement. Okay, we'll pull the pin out, and watching our dial down here, we'll come up to 8. And whatever's closest, whatever that'll fit into, that's what we'll use. Pin out, move up to 12, and looks like we're closest to 97. Okay, lock it into place. Let that drill bit do its cutting. Don't force it. Just leave your pin at the 5 position, remember. And now we'll go up to the next demarcation. Which is usually considered to be whatever's closest. It looks like 11 closest. Okay. Unlock, turn the pin. Ourselves up to 20. Whatever's closest. 14. Loosen it up. Where's the pin closest to the 24? That's right, okay. Lock it into place. Pin. 28. 22 is closest. Okay, all 8 holes are now drilled into the, oops, almost knocked into next week. So as you look, we've got pretty even spacing for the most part. But we're able to divide all 8 holes by using the dividing head and the piston. Of course, I went and I deburred the inside of the piston using a 3/4 inch end mill. And this piston's done, ready to be stamped for the number of the build. This will probably be number 2. And I've got to do this 7 more times. Hope you enjoyed this part of the build on the 9-cylinder radial, and watch for more. Thank you.